For decades, enterprise architecture faced two primary bottlenecks: storage capacity and compute power. We solved those. Cloud infrastructure provides virtually infinite space and processing speed. But removing those limitations exposes a new, more dangerous bottleneck: data trustworthiness. In 2014, Amazon utilized their massive compute capabilities to develop an AI recruiting tool. The system ingested thousands of resumes to identify top engineering talent. The historical input data, however, was skewed, causing the tool to actively discriminate against female candidates. The high-capacity compute failed entirely because the underlying data could not be trusted. 2 years later, an investigation by ProPublica analyzed a commercially developed algorithm used by judges to predict criminal reoffense. The investigation revealed the system was heavily biased against Black defendants. Ungoverned data processing creates severe, real-world ethical and regulatory liabilities. When IT departments attempt to address these liabilities, they often fall into a common trap. They confuse data security with data governance. Data security is strictly mechanical. It involves the implementation of firewalls, encryption, and identity management to prevent unauthorized access and exfiltration. On the opposite end of the spectrum is data enablement. These are the tools and processing engines that knowledge workers use to extract business insights from the data they have collected. Data governance operates as the distinct intersectional policy layer bridging the two. It dictates the exact rules of engagement, specifically how, when, and why data is accessed. This creates a central tension in modern architecture. Most enterprises operate in a rigid default closed posture, restricting business data to a need-to-know basis. The goal is to move to an agile default open posture. Democratizing data without this intersectional policy layer broadens a company's liability footprint with every new user granted access to the system. A robust governance framework provides the structural engineering required to safely unleash data democratization across the entire organization. Establishing that trust requires a first principles approach. True data trustworthiness relies on 3 interdependent pillars operating simultaneously within a tripartite framework. This diagram outlines the framework, starting with discoverability. Data provides zero business value if your knowledge workers cannot locate it. This relies heavily on metadata management and high data quality. Users need a searchable technical metadata catalog. They must be able to shop for data, viewing its full context, origin, and lineage before they even initiate a query. Providing that level of discoverability without boundaries creates massive risk. This requires the second pillar, security. This encompasses both broad regulatory compliance, like managing personally identifiable information for data privacy, and the specific internal mechanics of data security that prevent malicious leaks. These 2 pillars cannot exist in silos. They require a structural bridge governed by strict logic, classification, and access control. Master data management is the tool used to ensure data is finally classified. This prevents inadvertent data leakage across the bridge between discoverability and security. Precise classification rules determine exactly which discoverable items can bypass the security blockades for which specific users. Technology alone cannot govern a system. The architecture requires a human operational model, forming the third pillar, accountability. This establishes specific human operational boundaries. Governors are the executives who own the data domain, and stewards are the IT personnel who implement the actual access mechanics. Establishing strict ownership prevents systemic ambiguity. When a user requests access to a dataset, the system knows exactly who is accountable for approving it. Only when discoverability, security, and human accountability are mathematically linked can an organization truly trust its data infrastructure.
We can translate this theoretical framework into a practical, production-level implementation. Consider a standard enterprise human resources database. This dataset contains highly sensitive elements mixed with general corporate information. This chart shows a classification matrix. It converts the tripartite framework into executable database logic, mapping specific user groups to access control policies, data classifications, and individual data elements. We begin by examining a static baseline rule within the internal classification tier. Following the logic path, the taxonomy groups all employees under an internal classification. This grants the entire workforce indefinite read-only access to benign elements, such as a colleague's date of hire. We contrast this with a strict restricted classification tier operating within the exact same HR taxonomy. Following this restricted path, payroll managers are granted targeted access. They can view and process highly sensitive data elements, like an employee's direct deposit bank account number. This matrix structurally guarantees that a user sees exactly what they are permitted to see. It proves that proper governance is granular, operating on the element level, rather than relying on blunt IT firewalls to protect the entire database. Static baseline rules, even granular ones like internal or restricted, are insufficient for modern, agile business operations. Organizations require dynamic, context-aware governance policies to function efficiently. Looking at the People Manager's user group demonstrates how complex relational logic is handled. The policy node grants this specific group read and write access to the highly restricted salary data element. The matrix includes a crucial relational caveat. Access is mathematically restricted to the manager's respective reports only. They cannot query the entire company. The policy also applies a temporal limitation, requiring a reassessment in 3 months, preventing indefinite credential bloat. If a user falls outside these standard parameters, they trigger a workflow for new data acquisition. They search the catalog, find the necessary data stores, and submit a request including their intended use case. The data steward then reviews the request. They determine if the stated business justification is valid and if the data requested will actually serve that use case before provisioning access. This highly specific, time-bound matrix logic is exactly what allows enablement tools to rapidly and legally process complex queries without violating compliance. Dynamic provisioning acts as the mechanism that safely converts a rigid, default-closed system into a trusted, agile, default-open ecosystem. Scaling this concept from a single HR matrix to a global enterprise cloud architecture reveals the ultimate value of the framework. Imagine a knowledge worker initiating a complex cross-departmental query that spans sales, HR, and supply chain databases across this vast network. In a split second, the governance layer engages. It begins by checking the metadata catalogs to establish context and lineage for the requested data. Next, the system dynamically verifies the data classifications against the user's current identity and temporal permissions. Simultaneously, the system securely logs the entire action in an immutable audit trail to ensure strict regulatory compliance. The final result is the delivery of a clean, trusted, and legally compliant data payload directly to the end user's enablement tools. This operationalized workflow allows an organization to truly treat its data as a reliable internal product. Increasing data volume and deploying powerful enablement tools without this framework guarantees systemic failure and massive legal liability. Data security protects the perimeter. Data governance protects the asset's integrity and usability over time. Strategic data governance provides the deliberate structural engineering required to confidently unleash information across the enterprise.